Assalamualaikum, my name is Irene and I will be introducing what is material modification. Radiation material modification refers to the use of ionizing radiation to alter the physical, chemical, and biological properties of materials by enhancing the mechanical strength, adjusting molecular weight, and improving temperature or chemical resistance of the material. It can significantly expand the application and performance of the materials. This technology is widely used in various industries, including healthcare, automotive, aerospace, and electronics. There are several types of radiation source used for material modification. First, there is gamma radiation. It's derived from radioactive isotope like cobalt-60. Gamma radiation is highly penetrative and suitable for treating dense material. It is commonly used for sterilization and improving the mechanical properties of polymers and other materials. Second, electron beams or E-beam. This technology uses accelerated electron to modify materials. It offers high dose rate and is effective for surface treatment and cross-linking polymers to enhance their strength, chemical resistance, and thermal properties. E-beam is also used in the semiconductor industry to control the electrical properties of silicon wafer devices. Lastly, there is X-ray radiation. It produced by converting electron beams into X-ray. This method combines the deep penetration of gamma rays with the high dose rate of E-beam. X-ray radiation is used for treating bulky products and has application in both material modification and sterilization.
Assalamualaikum, my name is Erina. I will present on industrial application. Material modifications involved in several industries, for example, electrical industry, which is wire and cable insulation, automotive industry, which is car tires, packing industry, which is food wraps, and lastly, water treatment and environmental, which is wastewater purification. So, we choose wastewater treatment industry as a focus of our topic. Wastewater treatment removes impurities from sewage before it reaches natural bodies of water like rivers, lakes, and oceans. Typical process flow involves three steps, which is primary treatment, secondary treatment, and tertiary treatment. Primary treatment removes about 60% of total suspended solids and about 35% of biochemical oxygen demand (BOD). Secondary treatment removes more than 85% of both suspended solids and BOD. Tertiary process can remove more than 99% of all the impurities. Radiation-based material modification in wastewater treatment involve the use of ionizing radiation, which is gamma rays, to alter the physical or chemical properties of contaminants or pollutants present in wastewater. This table displays the differences between gamma rays and typical process flow of wastewater treatment. For effectiveness, gamma rays have high effectiveness than typical process flow. For duration, gamma rays have rapid duration while typical process flow has varies duration. For chemical residues, gamma rays does not leave chemical residues, while typical process flow may leave chemical residues. Lastly, for environmental impact, gamma rays has minimal environmental impact compared to typical process flow.
Hi, I'm Fuzaz Raya Muhammad Fauzi and I will explain about the use of material modification. First and foremost, material modification is used to enhance disinfection. Gamma ray penetrate deeply into wastewater, ensuring the root inactivation of pathogenic microorganisms throughout the volume. Secondly, it improves biodegradability by breaking down complex organic molecules. Radiation facilitates their decomposition by microorganisms in subsequent biological treatment stage. Next, oxidation of pollutant. This is because radiation generate reactive oxygen species, are known as ROS, that directly oxidize and degrade various organic and inorganic contaminants. Lastly, the benefit of using material modification are effective against resistant pathogens. degrade persistent organic pollutant, and reduce reliance on harsh chemicals.
Assalamualaikum, my name is Nur Faridama binti Rosli and I will explain the instrumentation used in this system. These are the instrumentations that are commonly used in the wastewater treatment using gamma radiation. The isotopes that are typically used is either cobalt-60 or cesium-137, which are encapsulated in a stainless steel to ensure safety and the durability of it. This system also uses the irradiation chamber. The chamber is typically made out of lead to provide shielding from radiation. A conveyor system transports the wastewater containers through the radiation field. Next, we have the wastewater circulation system, which is crucial for handling and storing wastewater. Radiation-resistant tanks and containers are used to hold the wastewater. Agitators are employed to ensure homogeneous mixing. Pumps, pipings, and valves are essential components that circulate the wastewater through the irradiation chamber. There are three types of water tanks used in this system. The first one is reactor water tank. This water tank ensures the effectiveness of treatment removal of the wastewater through controlled reactions enhancing contaminants removal. The second one is sedimentation tank. This tank separates solids from the liquid phase, improving the quality of effluent and reducing the load on further treatment process. The last type of tank used is equalizer tank. This tank stabilizes the flow and composition of wastewater, ensuring that the consistent and efficiency of the operation is maintained throughout the entire system. Dosimeter, specifically thermoluminescent dosimeter, is used to measure the dose of radiation absorbed by the wastewater. This instrument is crucial for monitoring and ensuring that the radiation levels are within the safe and effective limits. The process of wastewater treatment. First, the wastewater enters the system and is collected in the effluent tank. This tank is crucial as it stores incoming wastewater and helps in equalizing the flow and load before moving on to the next stage. During the pre-treatment, larger particles and debris might settle out or be removed. This system is essential to prevent clogging and damaging to the downstream equipment, ensuring smooth operation of the treatment process. Next, the wastewater passes through the gamma radiation irradiator. Here it is exposed to gamma radiation, which effectively disinfects the water and breaks down the organic and inorganic contaminants. The high-energy gamma rays kills the pathogens and degrade complex molecules, making it an efficient method for contaminant removal. After that, the wastewater enters the reactor tank. This stage involves additional treatment which include chemical precipitation to remove contaminants or biological process where microbes are break down into organic matter. Following the reactor, treated wastewater flows into the sedimentation tank. In this tank, suspended solid settles to the bottom due to gravity, forming a sludge. This step is critical for separating solids from the liquid phase. The clarified water then enters the equalizer tank. This tank plays a vital role in evening out the variation in the flow rate and composition of the treated water, ensuring a consistent quality of effluent. Finally, the treated and equalized water is ready to be discharged. This water meets environmental standards and can be safely released into the environment or reused, completing the wastewater treatment process.
The principle used for this water treatment is gamma irradiation. The principle of gamma irradiation for wastewater treatment is based on ionizing radiation generating reactive radicals. When gamma rays interact with water molecules, they form hydroxyl radicals, which are highly reactive and oxidize organic pollutants. This oxidation process breaks down pollutants into smaller, less harmful molecules, effectively reducing the chemical oxygen demand (COD) and biological oxygen demand (BOD) levels. Gamma irradiation effectively treats industrial wastewater by generating reactive radicals that degrade pollutants and disinfect the water. Now, let's go through the specific steps involved in this process. First, radiolysis of water. Gamma rays interact with water molecules, causing the water to break down into hydroxyl radical OH, hydrogen atoms H, and hydrated electron. Second, radical reaction. The hydroxyl radical and other reactive species then attack and degrade the organic pollutant present in the wastewater. This leads to the breakdown of complex molecules into simpler, less toxic compounds. Third, reduction of pollutant. Through this reaction, the chemical oxygen demand (COD) and biological oxygen demand (BOD) are significantly reduced, as the pollutants are transformed into carbon dioxide, water, and other benign substances. Lastly, disinfection. Gamma irradiation also effectively kills microorganisms, including bacteria, viruses, and protozoa, by damaging their DNA and cellular structure, leading to their inactivation and ensuring the treated water is disinfected. This process is advantageous for treating various industrial effluents, including those from pharmaceutical, textile, and chemical industry, as it can handle high pollutant loads and complex mixture effectively.
For regulations, I will explain about international and Malaysia regulations that related to wastewater treatment industry. For international regulations, firstly we have the International Atomic Energy Agency (IAEA). IAEA enhance global nuclear safety and security by identifying and promoting best practices and safety standards, and implementing programs to assist states in implementing these standards. It provides a variety of advisory and support services to help states strengthen nuclear security, including by enhancing the security of vulnerable nuclear and radiological materials, reducing the risk that such material could be acquired by terrorists. Next, the International Commission on Radiological Protection, ICRP for short. ICRP is an advisory non-governmental organization established to advance for the public benefit the science of radiological protection, in particular by providing recommendations and guidance on all aspects of protection against ionizing radiation. ICRP proposes protection policies and principles aimed at both legislators and regulators, operators and licensees, and members of the public as a form of recommendations. Lastly, International Standard Organization (ISO) standards. ISO develops and publishes standards for a vast range of products, materials, and process. Currently, the organization has over 24,362 standards which are included in the ISO standard catalog, which is broken down into various segments such as healthcare technology, railway engineering, jewelry, and more. Standards such as ISO 21238 on radiation protection shielding and ISO 27048 on environmental radiation monitoring are applicable. For Malaysia regulations, we have Environmental Quality Act 1974. These regulations provide guidelines and standards for the discharge of industrial effluents, including treated wastewater into water bodies. They set limits on various parameters to protect the environment and public health. Next, Radiation Protection Basic Safety Standards Regulation 2010. The regulations provide standards for the safe use of radiation sources, including gamma rays, to protect workers, the public, and the environment from radiation hazards. They specify requirements for radiation safety, radiation monitoring, and the management of radioactive waste. Lastly, Atomic Energy Licensing Act 1984. This act regulates the possession and use of radioactive materials and radiation sources, including gamma rays. It covers licensing, safety standards, and compliance requirements for activities involving radiation.
There are many risks of gamma radiation in wastewater treatment. Workers who handle cobalt-16 and cesium-137 are having a higher chance of getting cancer. Meanwhile, in handling and transporting process, there is a possibility of contamination of equipment and facilities. This potential for leakage or spill leading to widespread exposure. Cobalt-16 and cesium-137 has a specific way to be disposed. This is because the risk of improper disposal leading to environmental contamination. In emergency situation, whether the equipment is burned or exploded, cobalt-16 and cesium-137 can release radioactive material into environment, exposing radiation to worker and nearby population.
Risk prevention is a critical aspect of handling gamma radiation. In order to protect the workers, it is important to regularly monitor radiation levels in the workplace and restrict access to the areas with gamma radiation sources. Implementing these measures help minimize the exposure and ensures that the working environment is safe. When it comes to handling and transporting radioactive materials, security measures must be in place to prevent theft or tampering. Additionally, strict regulation must be followed to ensure the safe transportation of these materials. These steps are essential for maintaining safety during handling and transport process. Disposal of radioactive waste must adhere to the national and international regulations. Accurate record keeping is essential for tracking all the radioactive materials and their disposal. In the case of emergency situation, it is crucial to have an updated emergency response plan to conduct regular emergency drills and training sessions to ensure preparedness of workers.